Expanding Mind with Erik Davis and Maja Daoust. Thursdays at 2 p.m. Eastern Time on the Progressive Radio Network.
Welcome, folks, to another edition of Expanding Mind. This is Erik Davis, your host, exploring the cultures of consciousness. Today we're going to be talking about outsider physics with science writer Margaret Wertheim. I think like a lot of people who are, interested in the things we talk about on this show, I have long been fascinated both with physics and with sort of weird physics, or not exactly physics. If one is not trained in science, then really all you have to rely on are good popular accounts, secondary sources, whatever math you came out of high school with, and you can get some idea of what's going on in quote-unquote actual physics, and of course the ideas of quantum mechanics and Einsteinian relativity, and even some 19th century ideas about the sort of Maxwell's equations describing electromagnetism. They're very fascinating things if you're interested in philosophy, the nature of the world. In other words, if you're not just interested in what science has to say about quote-unquote true reality. But as you read this stuff, you start to realize that it's pretty hard to kind of hold it down without the math. At the same time, you start to see the way that certain ideas can be interpreted in very peculiar ways. You can start running with the quantum physics football, and then you look around and you realize you've wound up in a kind of new age place of magical relativity. That's also kind of interesting, and I think like a lot of readers, I've been drawn also to sort of alternative accounts of physics or alternative interpretations of quantum mechanics, etc. But there's a certain point, a couple of years ago really, where I realized that the really interesting question is sort of looking at the way that quote-unquote real physicists or real scientists police the boundaries of what is real science. Because that's in a way like where the action really happens. So instead of going to, some new age guy who's maybe has no more math than I do and like listening to what they have to say about quantum physics, or, going to, some science writer who's just going to kind of give me the mainstream view or interpretation of non-locality or, some particular factor, I would go, when I had the opportunity, and talk to scientists and say, like, I don't understand how you think about this weird stuff in a way that sort of makes it seem sort of reasonable, because you guys are not saying that the world, at least I don't think you're saying that, this new age magical reality has any real basis in the physical facts. And I discovered when I started asking these questions and reading these accounts that it's a very interesting way to understand how science works, to see the way that scientists police the boundaries. Who gets to speak? What kinds of assumptions are absolutely required? What kinds of axioms, to use the mathematical or logical term, are absolutely required in order for your statements to have any kind of real weight? Because that's where a lot of the action goes along. That's where the sort of wars about reality go on, is on this level of axioms. And so I was incredibly excited to read Margaret Wertheim's new book, Physics on the Fringe, because she's really going from a perspective of being a popular science writer with a real background in physics and the math, looking at this question of outsider physics and how we think about it and how it's policed and how it organizes itself and why it's there and how rich a world it really is. So very happy to have her on the show. But, of course, first we're going to bring on our co-host here on Expanding Mind, Maja Daoust. Maja, how you doing?
I'm doing good, Erik. How are you?
Pretty good. I bet you were excited. You're excited about this week's stuff, too, because I know you have that interesting science background in the midst of all your witchery.
Totally. And, you know, it's funny because like you were saying, I'm always very interested in the policing too. And I kind of think, I like to look at what's happening with popular modern physics with kind of like what's happening with the music industry too. Like there seemed to be this like who gets to speak. Like there's the industry that picks like who's Britney Spears and that's who they're going to put out, right? And who's going to be like the next pop star and that goes global. But then because of like the internet and more accessibility and all the indie stuff, like suddenly all these dirty kind of creepy people with maybe no kind of music education can just go ahead and start and actually make good music and infiltrate. And I kind of think it's similar with what we're seeing in pop culture with like, you know, like you said, with the new agey physics stuff. People are getting access to this information, and anybody can think about physics, and anybody can think about the ramifications of, you know, what are some of these scientific laws, and they don't maybe necessarily have to have that background, but because they're getting access, I think that's kind of what's kicking up the policing borders to have like these different, you know, kind of reactions to them.
Well, one of the things that Margaret talks about in her book is, you know, back in the 70s, if you were, you know, some weird outsider physicist sitting in your shack somewhere in northern Montana coming up with very unusual models of space-time, you know, you were probably writing it out by hand or you were typing it and maybe you were doing little diagrams. But now you can have all of these really powerful-looking tools, and moreover, you have this publishing medium and a network of people who are doing similar kinds of things. So invariably, it takes on more reality. It takes on more sort of substance, even if the actual material is still as outlandish to conventional scientists today as it was in the 70s. But even the term conventional science isn't exactly accurate, as Margaret talks about in her book. So let's bring her on right now, and instead of talking about her, talk to her. Hi, Margaret.
Erik, hi. Lovely to be here again.
Yes, wonderful book. Congratulations on that. I know you've been working on this for a long time. I mean, I thought maybe one place to start was just talking about when it was in your own studies of physics and your own sort of move into science writing that you became interested and indeed started to collect outsider physics materials.
Well, I actually had trained as a physicist in universities in Australia, and I actually heard about the phenomenon of outsider science about the time I was just finishing my physics degree. And, you know, a physicist friend of mine at the university had got something in the mail, and he told me it had gone, you know, straight from the mail room into the bin. And I remember, like him, being a bit affronted, you know, what drives somebody with no training in science to think that they can answer the great questions in physics without even having a degree? You know, as someone who just slogged their way through final year exams, I thought that was a bit outrageous. At the same time, some part of me was immediately interested. What sort of a person imagines that they can succeed where Einstein has failed, you know, to unify the whole of physics? What sort of a person with no degree in science has, as it were, the hubris, the confidence, the chutzpah to think that they can do that? And about 20 years ago, in my work as a science journalist, I started occasionally receiving these things in the mail. People had read something I'd written and they started sending me their own theories. And unlike most people who get sent this stuff, I started keeping them because I didn't really know what I'd do with them, but I thought it was just an intriguing phenomenon. And as they began to build up on my shelves, I came to realize that there was an awful lot of this going on, a lot more. It wasn't just one or two isolated people. There was actually a lot of it. And it seemed to me that whatever else this was an interesting commentary on science in our own day. It was kind of an interesting, as it were, backwards response to science. And I decided that I needed to write something about what it meant.
Well, you know, one of the nifty chapters in your book is where you kind of go through your collection and you kind of give us a sense of the range. And it's really extraordinary. I mean, there's even whole categories of outsider science that you don't even deal with because there's really so much, you know, especially now, but even historically. And you know, I'm kind of curious, like, is there a way for you to sort of generalize about that material, either in terms of the kind of personality or attitude that's reflected in the text, or in terms of some of the key ideas or key heresies, if you will, that many people keep coming back to?
Yes, well, both of those questions are good, Eric. I mean, in terms of the tone or the, as it were, ambience of these theories, the main thing that they have in common is that they're all completely outraged at what they see as the nonsense coming out of the physics mainstream. They think that ideas like four-dimensional space-time, and particularly things like, 10 or 11-dimensional string theory, are just, as it were, abstract supernatural nonsense. And they all say that very, very pointedly, that what they're responding to, what they're reacting against, is the fact that they think that mainstream physics has been captured, essentially, by some mathematical elite who speak this abstract language that only, a few people with higher degrees in mathematics can comprehend, and that as it were, they make the claim that nature speaks a language that the common man ought to be able to understand. Now, whether that claim is true or not, I think it's a sociologically interesting one. And so what they're all saying is, look, the physicists have gone off their rails. They're giving us all these things you can never see or feel or touch, or most of us can't even imagine, like, multidimensional universes. And what they claim is that the author of this theory, has seen the one true, simple insight that 300 years of physicists have missed, and if only they'd pay attention to my one true, simple insight, all the major problems of physics, or many of the major problems of physics, would just dissipate. So they all have the confidence that they, working alone, have seen the true inner workings of nature, and that it's a fairly simple thing.
Well, and the interesting thing about that, too, and maybe you found this as well, is that they come to that through an actual experience that they have, whereas a lot of the physicists get so in their head with the math and the kind of imaginary realm, which, of course is part of reality as well. But it seems to me that a lot of the fringe physicists are like doing something, like they're surfers or they're, mining for gold, and they see the thing in the thing that they're doing and they like witness it. Did you find that to be kind of true?
Yes, I think that's a very perceptive insight. The way I've come to think of this, Marsha, is that I think these people are really very much, many of them, in the 19th century mold of the scientist. The late 19th century is the time when science in general got fragmented into what we would now call theoretical science and practical science. But before the very end of the 19th century, almost all the people that we would now call physicists, they were very practical people as well as theoreticians. So they would be doing the mathematics, but they'd also be doing things like, building little mechanical contrivances or, inventing plumbing fixtures. They could build and do stuff as much as they could, with their hands, as much as they could build and do stuff with the equations. So there wasn't this separation. They were deeply engaged with the tactile physical world. And so are my guys. They are very, very tactile. They literally use the word common sense, and they mean that, intellectually, but they also mean, sensibility. They want to bring physics back to things that you can see and touch and feel, ideas that you can look at and say, oh, look, I can see that model of reality. I could build something like that. So there is this, as it were, tinkerer notion running through this outside of physics universe too. And again, that's very much in common with the way science was conducted up until the late 19th century.
Well, that was one of the wonderful things about your book, was how you introduced us to science and physics in the 19th century and showed the relevance of these issues and transformations that occurred there to the contemporary situation, both in terms of really ingeniously setting up certain, what history now regards as real physicists, and showing how some of their own activities, ideas, and practices in many ways resemble some of these outsider physicists more than they resemble some of the mainstream physicists of today, and that was very interesting. But the other thing I got on a sort of bigger picture level, which is something that I was introduced to this fall when I read a very strange but fascinating book by a 20th century heavy-duty Catholic theologian called Jacques Maritain, and he was an extremely intellectual fellow while still being very much in the school of Thomas Aquinas, but because he was such a smarty pants, he could really grapple with the physics of his day, as well as a lot of pretty impressive philosophy. And one of the most interesting things that came away from this experience of reading this extraordinary and very unusual book, The Degrees of Knowledge, was the way in which physics and physical accounts have been, in a way, they're sort of hijacked is the wrong word, but how much they have made a pact since the late 19th century with mathematics, and that mathematics is a very strange world. It's a world of all of these possibilities, many of which are completely bizarre, and it moves in multiple dimensions, and there's just this strange abstract language that peculiarly seems to often describe physical reality at a very complicated level, enough that physicists start going, well, if the weird math was able to predict or explain or at least be reflected in this set of physical phenomena, maybe it does it for the whole thing, so let's just go with the math.
Well, I mean, let's talk about this issue of the relationship between physics and math, because I think this really gets in many ways to the heart of the phenomenon, both of outsiders and insiders. It's absolutely true that in the 19th century, in the late 19th century, a big shift took place in physics, where it began to be much more highly, it began to use much more highly abstract mathematics in its accounts of reality, in its accounts of the physical world. Now, so things like group theory and tensor equations, these are the kinds of things that you're not going to learn in high school maths. So you do really now need to be professionally trained mathematicians to engage in physics from the late 19th century on. Now, the interesting question here, is why did that happen? And it happened for very practical reasons, in one respect. One of the great innovations in physics, one of the most important moves in physics in this direction, it's one of the most important moves in the history of physics, full stop, which was when James Clerk Maxwell, who was the Newton of the 19th century, came along and wrote out what are now called Maxwell's equations, which are these equations to describe how electric and magnetic fields behave. Now, these are difficult equations to understand, but he didn't do it because he was trying to be abstract. He did it because he was trying to describe, in some language, and mathematics was the language that seemed appropriate, how magnetic and electric fields interacted. So scientists prior to Maxwell, particularly Michael Faraday, had discovered, for instance, that when you move a magnet near a wire, it will force a current to flow, or that a current flowing through a wire will induce a magnetic field around it. How was one to explain this? For 50 years, people understood these phenomena as something that you could do, but nobody had any way of actually describing what was going on. And Maxwell and Faraday both spent years trying to describe it in terms of some kind of mechanical interactions. But then Maxwell came up with these very abstract mathematical account. And the thing about this is that the account worked. It literally worked in that it made concrete predictions. And the great proof of this is that from Maxwell's equations, he predicted that light was electromagnetic waves. And in the 1880s, Heinrich Hertz set out to find these radio waves that Maxwell's equations predicted, and lo and behold, he found them, and that brought into being the new era of telecommunications using radio waves. So physics is the language, physics is the science that seeks to describe the world around us using mathematical equations. And what's happened over time is the mathematics has become more and more abstract. But it's not because, in any sense, physicists want the mathematics to become more abstract as a philosophical principle. They just find themselves using more and more mathematical abstraction, because that's actually what seems to be describing predictively nature.
Well, and this is interesting, and I think this is something that is like the discrepancy that happens, is that math, like any other language, is a language. And I always have to go back to that thing, like once you name the Tao, it is no longer the Tao, and math is no exception to that. And I think that while those equations do offer these predictive abilities, and they can end up being true in a lot of things, there are also the ones that do not fit within the description, and then they invented statistics to get rid of the anomalies that didn't fit into the mathematical equations. And like you can look at Einstein's equation, like now they're finding, that light is not a constant, and so the math will have things that it can describe, but then there will be things that exist outside the parameters that the language of math can put in there. And to me, it seems like that while this math is a super tool that they can use as an abstract language, it still doesn't quite get the Tao under control. There's still things that are kind of left out.
Well, this raises a really great and philosophically and historically deep and important question, Marsha. And the first person to raise this question was Aristotle. And so, this has been a debate that's been going on for 2,500 years. And so the question that you're really raising is this: how much of reality, how much of the physical world, and physicists would say how much of reality as a whole, but let's be decent and say how much of the physical world can mathematics describe? Now, that remains an open question. Now, physicists today, many of them would tell you that ultimately all of physical reality, the totality of the world, will be described through a mathematical set of equations. This is what, in theory, the theory of everything is to do. Now, there are people who dispute that will ever be possible, and the person who most prominently disputed it was Aristotle. And this was Aristotle's argument, and I actually think it's still a profound and important argument. What Aristotle said was that mathematics, by its very nature, describes things that do not change. 2 is 2 forever. 4 is 4 forever. A triangle is always a triangle. So Aristotle said the fundamental nature of the physical existence is change. Therefore, mathematics is not the language with which we can ultimately describe physical reality. He accepted that we could use it to describe what was going on in the heavens, the motions of the stars and planets, because all Greeks believed that the celestial realm was a different eternal realm from the physical material world on Earth. But Aristotle insisted that because change was a fundamental aspect of reality, mathematics would never be able to describe what was going on in the material world. Now, that philosophy is held responsible for, as it were, in the historical narratives of impeding the development of mathematical physics for 2,000 years. So the revolution comes when you get to Newton and calculus. And calculus is a mathematics that's specifically invented to describe the phenomenon of change. And so,
and it's hilarious, too, because Newton was a fringe physicist, because he was all into the occult and, astrology. And I love bringing up him when we talk about fringe physicists, because everyone kind of accepts him as, a regular Joe. But in reality, he was a freak, He did astrology every day and studied alchemy and all that kind of stuff. So I love that also that calculus, the language these physicists are using to describe it, comes from this total religious zealot,
Yes. Well, we should make a distinction about Newton. Newton wasn't a fringe physicist. He was the absolute quintessential mainstream physicist, but he was a fringe everything else. He was, as you say, he was a religious fanatic, and he was a full-on alchemist who wrote far, far more about alchemy than he ever wrote about physics. But this debate about what can mathematics describe, I think, is the core of a discussion that our society still needs to have, because Aristotle's argument that mathematics cannot describe change remains a fundamental philosophical issue. So his point is that if everything is written into the formula in some way, then what that means is that nothing can ever truly evolve, nothing new can really come into being, that it's all, as it were, preordained in the equations, which means that in a fundamental philosophical sense, there is no such thing as genuine newness or genuine evolution. Everything was in the blueprint, and that is what the concept that Aristotle objected to. And I actually think it's a really profound point. Do we believe that true newness can come into being, stuff that's not preordained by, as it were, the cosmic blueprint? And if we do, where does it come from?
Yeah, it's
how does it come into being?
How that question of novelty, it also brings with it almost an inherent fuzziness, because if you think about some of the complexity science or the sort of sciences of emergence, and while I can't follow all the maths and all and all of the arguments, it seemed very clear to me that at a certain point in whatever the account of how something can emerge, something new, something integral, that we could not necessarily predict based on the equations. You just have to evoke a category of emergence. Something happens and then something new emerges, and that's sort of your description. And it's like, wow, but that's so fuzzy. So there's got to be a way to bring it down to a formula, or bring it down to to an algorithm, to some kind of functional description. And it's such an interesting point, because when you phrase it that way, and this is one of the things that's so fascinating about looking at outsider physics and the questions it raises just for all of us individually as people thinking about the world, even if we don't have these mathematical skills, is that you're like, oh, wait, actually, I do have something to say about that. I do have a gut feeling about that, even if I can't quite explain it. And that seems to be something that the outsider physics and Jim Carter, the main guy you talk to, do, is they take that gut feeling and they say, okay, well, let's take this gut feeling as far as we possibly can and stand on it.
Yes. That's exactly right, Eric. I mean, these people see, and I think they rightly perceive in some sense, that there are philosophical problems in mainstream science, and there actually are. They're right about that. Now, when you talk to physicists, it means insider physicists themselves, they acknowledge too that there are at least some of them many of them will acknowledge that there are deep philosophical problems, there are deep issues that we don't know. Like, we don't know how to unify relativity, general relativity, and quantum theory. That is a huge problem in the mainstream account of physical reality. Quantum mechanics is our theory of the subatomic, and general relativity is our theory of the cosmological, and these two theories don't mesh. So physicists themselves, when pressed, and will certainly discuss these problems. But I think part of the issue is that publicly they're prone to presenting a very arrogant, I hate to say it, but I think there is a terribly arrogant front face to physics in our society at the moment. And so the deep problems, the deep philosophical unresolved issues are not publicly acknowledged and not publicly discussed. And so when people who are thoughtful and care about science sort of, they have, as you say, Eric, these intuitions. Look, that doesn't really quite fit together. They don't necessarily know how to articulate it fully, but they do instinctively recognize that somehow the mainstream accounts aren't fully adding up. And I think the way forward with this is not to deny that we have these problems, but let's discuss them outright. And I think people like Jim Carter, who's the hero of my book, and the other outsiders that I write about, they're really trying to, as you said, go with their gut feeling and say, well, look, I sense there's a problem here. How can it be resolved? I can do this. I'm a sensible person. I love science. I understand the world. I work with machines and I fix things and build things. The universe is a great machine, and it's a machine that I can understand. That's a claim that Jim Carter makes all the time. And I think it would be very fruitful, actually, if physicists would be more willing to talk more openly about what these fundamental philosophical issues are and come out straightforward and say, look, we don't know everything. We're not on the verge of a theory of everything.
Well, and they won't even talk to other scientists. I mean, not all of them, certainly, but I think that part of that arrogance with physicists you're talking about is like they won't talk to biologists and they won't talk to astronomers, and these quantum physicists are trying to find the theory of everything, but then they won't even like look at the heavens or the stars, and you know, they won't open their own minds to include everything.
Well, I think part of what you're getting at here, Marcia, and I think it's a very real issue in science now, is that science, particularly since the late 19th century, has become increasingly the domain of super elite expertise. So here's someone who's an expert on neutron-deuteron scattering. He spends all his life doing that. And here's someone over there, she's a molecular biologist who focuses on, glutamine. And it takes a whole career now to really understand these things.
Right.
And so people's careers and getting tenure and keeping their jobs and actually simply doing the work with these big complicated machines actually takes somebody's whole career, teams of people's whole career, to focus on these minute things. Now, and so it becomes very difficult for them to explain their work to the person down the corridor who's spending equal amounts of time and energy focusing on some other problem. And we need that, or at least I think it's valuable in our society to have that, because all that specialization has produced things like microchips and the ever increasingly speedier and more brilliant microchips that we all rely on our, Apple Macs, for instance. Then, over there, the drug people are finding, incredibly powerful ways to manipulate drugs more effectively. These are benefits that our society has genuinely got. The question for me is, okay, we have the materiality, the working, what's called the instrumental view of science, the instrumental achievements of science, the satellites and the microchips and the effective pharmaceuticals. The question we have is all of this very, very, as it were, tunneled in microscopic stuff has also led us to a theory of the universe which is now incomprehensible. And one of the things that I talk about in my book is I think that we need to look at that science has another role, as well as producing the stuff that works, as well as its instrumental function. Science also has a function, which I call its cosmological function, which is to tell us what our cosmic home is. This famous line by the complexity theorist Stuart Kauffman, that what science does is to help us to feel at home in the universe. Well, the question at the heart of my book is, who gets to feel at home in the universe described by general relativity and string theory?
Well, that's a wonderful place to take a pause, because we got to take a break here on Expanding Mind. We're talking to Margaret Wertheim, author of Physics on the Fringe, and you're listening to Expanding Mind, and we'll be right back after these.
Welcome back to Expanding Mind on the Progressive Radio Network. I'm Maja Daou, and we're here with Erik Davis, and we're talking with Margaret Wertheim about crazy physicists. And before we left, you said something very important, which is who gets to be at home here. And I was wondering if you personally had faced any flack for making this book. I know there is an adverse reaction about these kind of subjects with the, kind of snooty physicists. And have you experienced any kind of repercussions for putting this book out?
That's a very interesting question, Martha, and actually it's been very interesting seeing the reaction. Many, many reviewers of the book have loved it and totally understood what I'm trying to do. Mm-hmm. But the negative reviews have all come from academics. Oh. And that does not surprise me. And they all seem to imply in the reviews quite strongly that I am doing two things which are unacceptable to them. One is that they say that I'm endorsing outsider theories as the equal of insider theories, and that's not at all what I'm trying to do. And the other thing, they accuse me of not sufficiently recognizing the difference between the two kinds of theory. And again, that is not what I'm doing. The purpose of my book is really to try to understand the phenomena as a social and psychological phenomena. Why is it that in the age of string theory, when alternative theories of the universe, when brilliant theories of the universe are pouring out of Harvard and Princeton, Stanford, by people like Brian Greene and Stephen Hawking and all the luminaries, why, when we've got this huge plethora of insider theorizing, does a man in a trailer park feel the need to reinvent physics from the ground up for himself? So my book's really a psychological and sociological study It's not meant to be endorsing
very clear
theory.
that that's what's going on. So it's so ironic that the academics, these people who supposedly are physicists, that are very smart people, can't get that little concept of your book. So to me, because I was perusing some of the negative reviews, and, you know, we've talked before, you know, about women in science and how a lot of people that are a little on the outside can face these things. And do you think it's because they feel threatened by it? Like, do you think that is the underlying thing that they're reacting to, or what exactly do you think is their problem with it?
You know, what I think it is, Margaret, I think that they feel threatened in some sense by the fact that there's a whole strata of society out there who are not buying in to the academic intellectual hierarchy. And that these people are making a fundamental claim that insider physicists are never going to get onto the right track, so we have to do it for ourselves. And I think that there is a sense in which it is like what you said in your introduction. It's a very great parallel with music. That, you know, once upon a time, music was produced by people like Bach and Beethoven. It was performed in courts, and the ordinary people, you know, had their own, you know, folk music, but they certainly didn't have, you know, this beautiful, graceful, you know, harmonious music. And now Beck in his bedroom can produce a record that he sells over the internet for millions and, you know, to millions and millions of people. And so I think part of what people are made uncomfortable by with my book is that what I'm showing is that there are thousands and thousands of people out there producing their own theories of physics in their, you know, backyards and bedrooms, and they're putting it out there, and it raises the question of how do the rest of us, how do any of us who aren't trained physicists decide which theories we're going to pay attention to and which ones we're not going to pay attention to? So, you know, if in the age of the internet, when anyone can publish a theory of physics online, how do we know, as it were, who to pay attention to, who should we listen to? And I think that's what makes these people uncomfortable.
Oh,
it's incredibly ironic on that score because you know, in a way, what you're saying is that there is always a sociological dimension to science, even true, real, absolute, no questions asked science. There's always it's always taking place in a social dimension, and where there's power, where there's media, where there's an unequal distribution of intellectual tools, et cetera, et cetera. And the irony is that in order to maintain or to shore up the power of the academic intellectual elite, they need to claim that sociology does not really ultimately figure in the determination of truth. They want to say that's why they're saying, oh, that you didn't emphasize the difference between a Jim Carter and real science enough, because if you insisted on that difference would help, and here's the irony, shore up their sociological power. So it's their very ability to pretend that sociology doesn't have an influence, or that history doesn't have an influence on science, that enables them to historically continue a certain attempt at dominating the conversation. But one of the things you do in the book as well that we haven't talked about is the way in which insider physics has changed. And the way in which insider physics has changed in a way that seems to kind of actually put it in a sort of resonance with some of these outsider exuberances. And, you know, anybody who has sort of been kind of casually interested in tracking quote-unquote real science, not New Age quantum physics stuff, but like, you know, what people are talking about in Scientific American and these sort of reputable organs of popular science. Anyone who's paying attention to this, who's been reading this stuff for the last 20 years, will have seen a remarkable uptick in weirdness over the last 10 plus years. And so even insider physics is changing in a clearly sort of historical or sociologically informed way outside of the specific reasonableness of any of their given theories. So I would love it if you could give us a little taste of that, because that was one of the fresher things for me about your book, was precisely your sort of account as a science journalist of going to one of these conferences and going like, wow, this is really weird.
Well, you're absolutely right, Erik. I mean, this is the thing that ultimately prompted me to write this book, was that in 2003, I went to the world, as a science journalist, I went to cover the world's first string cosmology conference. So this is the application. It's the first time that people had realized that they could take string theory, which had been invented to describe how subatomic particles behave, and they could apply it to the cosmos as a whole. So there was this attempt to sort of, as it were, expand string theory to produce basically a theory of the universe at large. And, Stephen Hawking was at this conference, and Paul Steinhardt and Leonard Susskind, all the great names in string theory were there. And it was the weirdest, most surreal event I have ever been to, because basically everybody got up and said, in their 20-minute presentations, they all got up and said, I've got a theory of the universe, here's my theory. Now, and after everybody's paper, the first question would always be something along the lines of, Professor Steinhardt, that was an extremely interesting talk you gave, but why did you start with the initial assumptions the particular set of assumptions you started with? And he would say, oh, well, I thought it was an interesting place to start. And everybody had their own set of initial conditions and their own set of initial assumptions, and they proceeded to go from there with the math. And afterwards, in the tea breaks, I was talking to people, and I'd say, well, what did you think of that talk? And everyone would say things to the effect of, utterly splendid, but there's not a shred of evidence for any of it. And it didn't matter who I talked to or what the paper was, there wasn't a shred of evidence for any of it. And after 3 days of this, I realized I felt like I was at the Mad Hatter's Tea Party. It was absolutely brilliant. It was illuminating. I mean, it was like being at some electric, acid-fueled, sugar-fueled birthday party. It was absolutely marvelous, but there wasn't a shred of evidence for any of it. And on the drive home, this conference was held at UC Santa Barbara in the Kavli Institute for Theoretical Physics, and on the drive home I thought, I have to write a book about outside of physics as a response to, in some sense, as Erik said, the weirdness of what the insiders are doing.
Well, and it's such a microcosm of science. Sorry, Erik, I just want to say a microcosm, because they're all presenting their unification theories, and none of them can even unify with each other on it, right? What you have a bunch of these individuals come together and say, I know unification theory, but you don't know it, and my theory can't go with yours, and they're arguing about who has the right unification theory. I mean, it's preposterous.
That's a beautiful insight, Margaret. But I mean, as it is true that the 2,000 or so string theorists in the world, they do share a common mathematical foundation. I mean, they've all been trained in the tensor equations of general relativity, which they all know how to manipulate fabulously. They all know how to deal with the Calabi-Yau manifolds that are meant to describe string theory. So these people, they do share a mathematical foundation. But it's been estimated by the string theorists themselves that the number of possible versions of string theory is 10 to the power of 500. Now, that's an unimaginably vast number. Just to put this in perspective for the listeners, it is estimated by physicists that we live in a universe which has 10 to the power of 80 fundamental particles. So that means that there are more possible theories of string theory than there are, by 400 orders of magnitude greater than the number of particles in the universe. So the question here, a big question the string theorists themselves are getting nervous about is, look, let's say I actually would have the correct string theory. Let's say me personally, I've got the correct string theory. How would we tell? When you've got 10 to the 500 to choose from, how would we even know which one was true?
And it seems like one of the changes that has happened over the last 50 years is that the willingness of physicists to engage with these theories that have no evidence and are unlikely to produce evidence in any immediate sense has exploded. Last summer we had we talked about the book How the Hippies Saved Physics.
It's marvelous, isn't it?
Wonderful, wonderful book. And one of the points that we were talking about was how physics in the 50s and 60s, they weren't interested in any philosophical questions, any quantum weirdness, none of it. It wasn't going to get you a job. It wasn't useful because there were so many practical things with physics to do. And then at a certain point, these fringe ideas started to gain a little bit of credibility, or at least a certain kind of momentum, and then ultimately they ended up, having real influences on some practical instrumental levels as well. So if you to think like as a historian or a cultural historian for a moment, I want to ask you, what do you think is happening, not necessarily within science, although that might be part of the answer too, but what is happening to create such a shift from the 1950s, where even a little bit of contemplation of the philosophical implications of quantum physics was verboten, to this conference you go to where it's just a Mad Hatter's party of mathematical possibility? What accounts for such a shift?
Well, that's a question that I think really matters, Erik, and I'll say a couple of things on that. I think a huge part of the shift has happened for an economic reason. That to make progress in theoretical physics now requires machines like particle accelerators and deep space telescopes that literally cost billions, if not tens of billions of dollars. To go to taxpayers and ask them to spend tens of billions of dollars on pieces of equipment, you have to have a very, very good justification for why they should. So as we've done, as it were, all the easy physics or the low energy physics, it actually does take more equipment and more money to make further advances. And therefore, I think by as it were sociological necessity, physicists have had to up the claim of what they're doing. So now we're not just finding a better microchip. We're finding the true theory of everything. We're looking at the face of God, as Leon Lederman put it when he was trying to sell the superconducting super collider to the American Congress. So the claims of physicists have been pushed up and up over the past 30 years because the cost of doing it has become so high. And I think this is actually a moral question that is allied now with high energy.
Well, but it also goes, it's moral and also philosophical and theological as well, because if they're really looking for the real face of God, the irony is, and the people that have made all these kind of bounds, like Isaac Newton and, Niels Bohr, the people that were looking to religion, that made the big breakthroughs, or on acid and got some mystical vision, you should be able to see that in your own face, in your own body, in a flower. Do you really think it is necessary to have these billion-dollar machines to be able to have this discovery? Or do you think, we can just tinker with a barrel and some smoke rings and be able to have it be revealed there,
Well, this is also an important issue, I think. Do we need this? I mean, personally, what I would say is I do actually think if we want to have a theory that unifies general relativity and quantum mechanics, we probably are going to have to do some very expensive empirical testing with both deep space telescopes and particle accelerators. The question is, do we as a society need to have a unified theory of general relativity and quantum mechanics? Both of them work extremely well. There's massive work that can be done with quantum theory we have, and it is being done to develop things like quantum optics, quantum information theory.
But that's the thing with the unified theory should be true on all levels, right? Not just the teeny tiniest. We're looking at the great big universe and the teeny tiniest particle, but then we don't look at ourselves and what we're doing, washing the dishes. If it's a unification true theory, it should be on all the levels, not just they're leaving out the whole middle.
One way I'm looking at what Maj is talking about, that maybe it's a sort of nuance of it, is that, again, one of the ironies here is that in order to justify the expense of, contemporary theoretical and particle physics that demonstrates these theories, as you say, in some sense, the physicists professional physicists have to play the God card. They have to play on a social level, on a sociological level, on a talking to Congress level, on a pop science level. You know, there's all these incredibly popular books by physicists that most people don't even end up reading because they can't quite follow them. And what are those books sold on? They're not sold on just science. They're sold on the sense that the physicists are still the closest to the theologians, that there's something about that metaphysical, mystical, theological domain that the physics are closest to. So they're in a bind. In order to get the particle accelerator, they need to say, we're looking at the face of God. But the moment that anybody else goes, well, you know, I saw the face of God once. I was outside, I was fishing, and I suddenly saw the ripples of the lake begin to reverberate, and I realized that I was a ripple in the cosmic fabric, and I saw the face of God. But from the physics, they're going to go, dude, you're leaving the hall right now. That is not what we're talking about.
This is not a shred of evidence.
They're in this kind of bind of like how to both appeal to this thing that so many of us have of wanting to get to whatever, whether you call it a fundamental theory or a narrative or a way of being at home or experiencing oneself as being at home in the universe intellectually and existentially. But at the same time, they have to constantly keep reminding people that only they get to do it.
Yes, I completely agree, Erik. And this intersection between physics and the rhetoric of God is what my first book, Pythagoras' Trousers, was all about. And I put forward the view at the end of that book that basically contemporary physicists are using God like a PR mascot. They're not looking at the totality. They're not even interested in the totality of what the word God means to most people, and then even within the Christian tradition. And as Marsha said, you know, there is a wholeness to the human being. There is a wholeness to the concept of God. And God is not just the creator of the universe, at least in the Christian tradition. He is also the redeemer of our moral sensibilities. And that is the primary function of God in Christianity. And none of that is encompassed by the theories of unification between general relativity and quantum mechanics. And so I think you're quite right, Erik, that there is this, I think the only way to say it is a form of hypocrisy. On the one hand, there's the utilization of God to sell these multi-billion-dollar machines to us. And on the other hand, when you actually want to have a discussion about what does God mean, and perhaps I've encountered God in my bedroom, you're not allowed to have that discussion at all because God is now said to be a supernatural being that's a fairy tale we have to give up. Well, which way is it, guys? Is God on our side or not? And I think that is a fundamental duplicity. And again, I think it does come down to the extreme amount of money. But I'd like to come back to that issue that we were talking briefly before, that Martha raised. Does our society need to be spending tens of billions of dollars trying to find the unification of general relativity and quantum mechanics? I think that's a question that ought to be put to the people. I have my own views on it, but I think this is the question that I think needs to be put to society as a whole. Do we, the people, think this is a worthwhile goal? And if we collectively say yes, let's do it. Let's spend tens of billions of dollars and do it. But is that actually what people want with their money?
You know, it's such a wonderful thing because, I mean, in my head, that clarifies a certain philosophical or even a religious response, which is that on that more philosophical level, what's driving the spending of the money and the attempt to find a unification theory is the faith that there is such a thing as a unification theory possible. Whereas I walk away from a lot of religious and philosophical investigations with a fundamental sense of the paradoxical, incomprehensible mystery at the heart of reality. And from that perspective, you know, maybe they're never going to unify this thing, so why spend the money that way? Because we got a lot of other things to do that are less incomprehensible and potentially much more helpful. But in order to do that, there has to be a general sort of sense that you're never going to see the face of God, or if you see the face of God, it's going to be incomprehensible, or you're not there because there can't be a you seeing the face of God, or whatever paradoxical formulation you want. But it is a kind of embrace of paradox and fundamental mystery that you find amongst a lot of more sophisticated religious philosophical thinkers, but it's not something that's often found among physicists, insider or outsider. And that seems to be an interesting place where the role of science itself as an explanation for the fundamental structure of the universe runs up against other very different kinds of narratives. So we only have a few minutes left, or a minute left, but I'd love to just hear you respond to that, and then we'll have to say goodbye.
Well, it's a wonderful place to end the conversation, Erik, and I'll bring it back to something that Mars said at the beginning. This is, I believe, the fundamental reason why physics is not the Tao. Because at the heart of the Tao and all the Eastern ways of knowing is the notion that you cannot ultimately name the thing. At the core of the, as it were, sociology of knowledge that physicists buy into is the idea that we can name the thing, we can write it down as an equation, and it's an obsession with the notion that we can literally articulate it in microscopic detail, whereas the Taoist would say, actually, you have to accept that at the core of everything there is an unknowing.
All right, well, we'll have to end there. Margaret Wertheim, thanks so much for being with us. Physics on the Fringe, you can go to the website. It's a great book to read. Thanks for being with us, Margaret.
Thanks very much, Erik.
Okay, from me and Maja, keep your minds open.